Hey everybody, I'm Dortz, and this is the BSOD tutorial on controlling user input. I'm dealing with users. Rule number 1, the user is retarded. Now, it's kind of an unfair statement. There are users out there who are not, but are just malicious and mean and want to break your code. But hey, that's allowable. This is only just a couple of things that you can do to prevent malicious people from breaking your code, or just plain user retardation. So, first thing to notice, we have the string class, and that will come up later. And we have a function multiply, which just takes two double values and gets an int back. We've got a double, which we preset to 1.3. Couple of variables to play with. String is declared just like any other variable. And we saw how to take in integers here. Typecasting. Now, this double take int is a typecast. Now, it's telling the compiler that in this instance only, take this integer value and treat it like it is a double value. So, multiply needs a double-double. It has x, which is a double. And for all intensive purposes, take int, which in this case is a double. So, let's drop right down to multiply, see what it does. It's just your double times your double. But the key here is it returns an integer. So this is called clipping, trimming, whatever. All it does is when it gets back up to here, it's gonna lop off that decimal. So if I sent it a 3, it's gonna come back a 3.9, but as an integer, so it's going to lop off the 0.9 and be just 3. As I state here, same can be found by just taking variable minus variable mod 1, which will just leave the remainder of the decimal places. But, so there's clipping. How about a hypothetical menu situation where you want options 0 to 4. Whoa! No, I cannot use mouse. Options 0 to 4. There we go. Now, I'm sure I did this in previous tutorial somewhere. Probably the while loop one. But hey, here it is again. I have a while loop. I have a Boolean flag set to false. So while it is not good input, it takes input. And it's just going to take in an integer value, check that integer value. If it does not fit in the required space, it redundantly calls it false, kicks back until it gets something that's good. The problem is, this does not protect against the G as a number situation, where the user inputs G here. It's going to make everything go to hell. Now I'll demonstrate that when we get over to the compiler side. But how to avoid doing that is to use strings. Remember, we have s is our string value that we declared previously. So we have enter a non-zero integer. So let's say he enters a v. It's going to go to ATOI. ATOI is one of the old C functions for manipulating strings that will take a C-based string, well, in the same form of C strings, and it will convert it to an integer. A to I. See? It makes sense. But it does offer the tricky part that we need to cast S as a C string for this situation, which is real easy. A C string is a subclass of string. All you gotta use is .c underscore str parentheses. And that's gonna convert it to a C string, and it can therefore be sent to ATOI and not spit crazy errors. So say it sends a V, which is not an integer, for those retarded people actually still listening to this. It's just gonna kick back a 0. Hence we need a non-zero integer. So gets 0, it's 0, so it's bad input. If ATOI gets 1396, it's 1396, it is good input and it'll kick out. So that's that easy to protect your data and protect your code from breaking horribly. So I'll see you on the compiler side to make sure that this stuff actually works. So over on the compiler end, notice I have already compiled it, the old method, G++, and it kicked out something a little interesting that I wanted to point out. It will give you a warning that you are converting an integer from a double value, which this is where we send from multiply. We return an integer after multiplying the two doubles. So it's, you know, informing you that you intend to clip. But hey, that's nice of it, I suppose. Let's jump right into it. Say we need an integer 5. So we have 5 times 1.3, which is 6 point something, but it doesn't matter because whoosh, when multiply sends it back, that decimal just gets lopped right off. So back now we're in the while loop with integers. 5 is invalid. So is 3, 4, 5, 6. But let's use a G. Yeah. It broke. It broke bad. So let's jump through it real quick. So now we have the non-zero integer. Now this was where we had the string. So I can put a G in, well, an F in here, and it just kicks bad input and sends you right back instead of going absolutely insane. But also, let's take note that there are input buffers for strings, and a space denotes the same as a enter character. So the space will kick bad input, brown space will kick bad input, fox enter will kick bad input. So how about the brown 5? Bad input, bad input. Now there's no return here. There's no carriage return here, so it will not go to a new line. Same thing as we saw here. It's just like bad input, and here it pops to, it gets 5 now. And just like a little interesting quirk with strings. But if somebody's going to input a sentence where a number is supposed to go, they're trying to break it anyway, so I wouldn't worry too much about your formatting getting all fucked up. I mean, you could put redundant formatting in there, but so anywho, that's your input tutorial. I hope you somewhat enjoyed my ramblings, and I promise next time I'm gonna have visual aids because I'll be going over some crazy stuff. So, later.
Hello, this